So I thought on this video we'd have a look at changing LGA sockets. Yeah, I mean I have a BGA workstation to do this with, and you've probably seen the BGA workstation on some of the videos. It's behind me, the big blue machine over there. Yeah, which is a 3-zone BGA machine, and I've used that, you know, to change LGA sockets before now. But I appreciate some of you guys won't have access to that sort of equipment. You know, I mean, that was like 3,000 odd euros. It was quite an investment to make, and I'm sure that as many of you are working with much more basic equipment than that. So I thought, well, we've got a scrap board here. This is the one that we, if you've watched other videos, we removed the PCIe socket to see if that was possible without damaging the board, which it was. We salvaged a lot of capacitors off this to fix the retro gaming motherboard, the one with both AGP and PCIe, and now I thought we'd have a go at removing the CPU socket, the LGA. This is LGA1156. I don't have any replacement ones, and anyway this board isn't working. I mean, I do have replacements for some others. So for instance, this is AM4 for AMD motherboard. So you can buy these, you know, if you go onto AliExpress. There's a number of sellers who sell these. So as I say, for example, this is an AM4 socket, yeah, off the Ryzen motherboards, and I have quite a few of these. These are socket 1151, LGA1151 sockets. Again, these are from AliExpress, and they're about €2 or €3, something like that, maybe 4 or 5 for the AMD sockets, but they're not expensive. And there's plenty of motherboards around with badly damaged pins, so there's definitely work there to be done. The main problem with these is not getting the socket, but it's actually doing the job. Yeah, let's put this back on the right way round so it protects it. Where did I take that off from? It must have come, yeah, it came from here. Okay, so now click that back on. So yeah, I have those. I don't have one for this motherboard, but it's irrelevant anyway because this motherboard has it was faulty. We've stripped quite a bit of stuff from it anyway. So yeah, let's see if it's possible at least to desolder this, yeah, without damaging the board. So that's without stripping any pads, any traces, without burning the board, you know, bubbling it, that sort of thing. Yeah, is it possible to do that? And is it possible to do that with just a hot air station and to give it a little bit of help, a preheater? Yeah. So the preheater I'm going to use is this one. This is the Carlos 853B. This is very inexpensive. They're about let's have a look how much they are on AliExpress. Let's see. So you're going to work it out. There we go. It's the Carlos 853B. Carlos 853B. Yeah. This is the preheater. See how much these things are. Ali's running a bit slow today. The internet's fast. It's just AliExpress seems to be running rather slowly today. Oh, there we go. Yeah. So, well, oh, that comes with a stand. Actually, I probably need to buy myself a stand. Yeah, so €35 there, €33 here. Yeah, €31 here. Are these with any postage? Let's have a look. Come on, internet. There we go. Yeah. No, with a lot of shipping to Spain. That's not helpful, is it? Let's have a look at another one. Oh yeah, because they've €20 shipping in. So okay, it's like just over €50. Yeah, it's about £40 UK, $60 maybe, something like that. And if we look around, we can probably find a better deal than that with free shipping. That one works out lower, so that one's like €43, €44. Yeah. So they're quite cheap. That's the Carlos. Yeah, so I'm going to use that as a preheater underneath the board. I'm going to use the quick 85861D. That's like a €200 hot air station, but you can get things like the Aneng 862D, which has been reviewed by a number of people and has a very similar performance to the quick, which I'm going to be using. And those are quite cheap. See, so we have the quick 861 DW, yeah. Those are going to set you back, yeah, 200 odd, yeah, just under 200. Okay, 168. We're getting a bit cheaper on those. And the other one is the Aneng 862 D. These are cheaper, yeah, so €150. So we're basically, with free shipping, yeah, €150 with free shipping. So we're basically looking at using like €200 worth of kit, yeah, here to actually do this job. The question is, with €200 worth of kit, can we actually do it, yeah? Can we actually do this? So let's give it a go and see. Okay, so we'll give it a go. I think the first thing was to get some flux under this socket, yeah. Seeing as the socket's no good, in fact it has a few bent pins, it won't be any good once we've removed it. I don't think you can actually reball one of these. So I'll put flux first around the edges of the socket, yeah, and then I'm actually going to put some flux into the socket itself. Obviously we can't really do that with the new one if we were replacing it, but in that case it's off the board, so we can get, you know, flux and spread it onto the board anyway. So let's try. I'll try setting the hot air to 400 as well. I don't want to scorch the board. I think I'm going to have to get quite a lot of heat into here. I think the trick of this is not going to be a problem of getting enough heat in. I think it's more going to be a problem of getting the heat evenly distributed, yeah, so we haven't got like mega hot spots and other spots that where the solder isn't melted that are going to strip the pads off the board. So let's get some across the top edge of that as well. Just got some flux there. I think if we end up damaging the board, it's more likely to be the pins near the edge, because we'll probably find that, you know, we will struggle to evenly heat this up. So getting flux under the edge is probably a very good idea. It'll probably give us a better chance of desoldering this without damaging the board. There you go, sort of running under there. Go for this side. I'm going to go twice round the chip. Yeah, doing this, just getting flux down all the edges. Okay, running down quite nicely. And so we'll go around one more time. So you don't need to watch me doing that one more time. I'll see you in a moment. Okay, so that's got flux under the socket, and I'm also going to put some flux into the socket. I'm going to take the needle off this. It's a bit difficult to get the flux. I'll probably get a fair bit more this way. There we go. That's what I want. Really is a nice load of flux on the socket itself. Yeah, some in the middle. That's not a problem. Okay. We've got a good amount of flux there. Okay. I'm sure that'll just melt in anyway. I don't need to do that. I mean, once we start heating this up, that'll melt in, yeah. So here's our preheater. I just knocked something over with the cable. Let me just move that there. So we need to get this socket pretty much centered over the preheater, which is there, yeah. And it's balancing quite nicely. Let me look underneath it. Yeah, that seems to be in the centre. I'll look from the side. Yeah, that seems to be pretty good. I mean, you can't tell exactly, but that seems to be pretty good. Well, we wanted a thermocouple. We wanted to see what's going on with the temperatures on here, yeah. And what's underneath the board as well. Yeah, there's a few capacitors here, but I don't think they'll fall off. I mean, this is an experiment, yeah. I don't think there's much mileage out of putting some Kapton tape on that. I mean, normally, I would imagine that the preheater isn't going to get the bottom of the board hot enough to melt solder, yeah. But the top is going to get hot enough. So let's use a couple of thermocouples. Let me get some tape, yeah. If I reach it one moment. Okay, I've got the tape. I'm going to put one in this corner and one in this corner, yeah. And that probably gives a good idea if we get an even distribution of heat, which is really what we want to try and do with this. So I mean, I say that I'm making this up as I go along. I've never tried this before. I'm not, you know, I have a BGA. I bought a BGA reworkstation for doing this sort of thing. I just became interested with the YouTube channel to see if it was possible with much more basic equipment. Okay, that's one thermocouple. Let me get the other one. These are dead easy, so if you haven't got one, buy yourself. You'll get two of these for about €8, yeah? They're about €4 each. So let's have one over there. We'll put one over here. And again, I'll just tape this down, yeah? So it's in place somewhere close to the socket. You like my way of doing this, yeah? Still nobody's chastised me for that. I'm waiting for the comments. I'm sure somebody will have something to say about that. So I said before, you won't get me to stop doing it, but you can feel free to have your say, yeah. Actually, this is quite handy because that little group of components under the board I can use to line up quite nicely with the nozzle. So we've got two of those. Let's just zoom out a little bit, yeah. It's very warm here, by the way, today. We have a Kalima outside. How warm is it? Oh, what's wrong with this thermocouple? Oh. It's one of my thermocouples packed in. Oh, it looks like it. It looks a bit burnt on the end, to be honest. I think. Let's just try and twist it together. Get it onto the board. I want it touching the board, yeah. Oh. So that's the temperature in the workshop today, and I've put the air conditioning back on actually. We have a Kalima. Kalima's something specific to the Canary Islands, to be quite honest. It's when we get hot air blowing from the Sahara Desert over the islands. So where temperature here normally, like in the winter, you're looking at like 21 in the day maximum, and minimum of maybe 14 at night. Yes, so about 7 degrees centigrade difference between day and night. And in the summer, it's about 28 in the day and 21 at night. So we get about 7 degrees difference. And between winter and summer, from the coldest day to the hottest day, normally it's about 7 degrees difference. So we kind of have this climate whereby I'm talking to you about this, so let's put this on. Let's do something useful, yeah. Yeah, so we have this climate which is very even here, but we get these Kalimas. Kalima can easily push the temperature up by 10 degrees, and they last, you know, from half a day to like a week, you know. And we've got quite a severe one at the moment. So our daytime temperature now outside is hitting 40. Heater. So hence I say it's rather warm in the workshop today, yeah. There we go. You see one side's warming a bit more than the other. So let's just try and see if I can position it so both sides are kind of warming more evenly, yeah. I mean, this one was reading a little bit lower than this one was all that before. No, I can't get it. It's not that much difference. While that's warming up, let's get ventilation fan. Yeah, so this is just a old fan. Those Kalimas, by the way, they can come any time of year. So if you get a Kalima in the winter, you're getting temperatures daytime like sort of 30 degrees and maybe 22 at night. If you get them in the summer, then it can easily go in excess of 40 in the day, and minimum at night maybe 28 to 30 minimum. Yeah. So the other thing with the Kalima, it goes cloudy all day. Hey, it looks like it's cloudy, overcast, but it's not actually. It's dust in the air. So the air gets heavily laden with sand and dust, and of course that all falls on us as well. So a Kalima, it can be just dusty but not hot. It can be hot but not dusty. And the bad ones is when it's hot and dusty. Yeah. And 2019 we had a severe one just before the COVID crisis. Beginning of March, and we made worldwide news. Apocalyptic sandstorm hits the Canary Islands, yeah, and that was awful. You went outside and you were just breathing in sand, yeah, it was everywhere, and it was hot. Fortunately, it was only maybe every 20 years we get one like that. I've only ever known one that bad. I've been here for 5 years. Okay, so nothing much more to chat about, so I'll just pause the video and wait till this gets up over 100 degrees. Okay, so you can see that's now starting to bubble, yeah. I've put the blower over here just to kind of like send all the fumes away from me, yeah. And we're not up to 100, but we're near, and the preheater's near to its maximum now. But we've got a nice around about 100 degrees into the board, yeah. And I can turn it up a little bit more than this. So let's take it to maximum, see if we can get any more heat or much more heat into this, yeah. I think this one's staying slightly lower because of the fan. Yeah, look at that. I'll try and put this a little bit further away so it's still blowing in the air. So we're near to 100, yeah, and that seems to be as much as we can get in with the preheater. So now I'm going to take the hot air and start to warm this area up. The tweezers, I've noticed, are like little holes in the socket, yeah, like a hole here. So this is probably how we can lift it, yeah. Producing quite a bit of smoke. I'm going to put the mask on, yeah. Got a face mask. Not just good for COVID restrictions, yeah. We have to wear these everywhere, indoors and outdoors. The only reason I don't have to wear one in the workshop is I keep the door locked, so effectively it's not a public place, yeah. But any public place, indoors or outdoors, apart from if you're eating in a restaurant. If you're eating and drinking, obviously you can take it off, but to go in the restaurant you have to be wearing it. And if like you leave your table to go to the toilet, I'm doing this just to see what the real temperature is, that's why I'm lifting. Yeah, so anyway, masks everywhere, yeah. I've clearly got a lot of flux in this. So if I lift this away, you can see it's still about 160 degrees. I'm just gently just tapping the socket to see if it's actually coming free out, which it isn't. I mean, this is the biggest nozzle I've got. I could have taken the nozzle off, I guess, and used the hot air without the nozzle. No, it's still not melted. That's gone over 200, so let's come a bit more on this side. Again, pointed away from the board, it instantly drops about 170, yeah, so you can see it's not really up to the temperature yet, and it's still not moving. Oh, One of the capacitors jumped out from the middle. That's not a good sign, is it? The capacitor actually just jumped out from the middle slot, so there's obviously getting heat in here. Well, it's still not unsoldered. Most of the smoke's gone now, so obviously a lot of the flux is boiled away. I'm going to increase the temperature on the hot air up to about 450. Okay, I'm on 450 now. So I'm obviously struggling to get enough heat into this. No, it's still not moving. I would have thought by now I'd have probably had got heat into this sufficiently, but obviously not. No. Ah, this is not going to work. It's actually, I've just seen the board go. I think. Yeah, it's delaminated the board. Let's see if he'll even come off. No. Okay, I've got it, but it's off. It's off. Switch the heater off. Just switch it to cool. Okay, I let that cool down. Well, I don't think we can call that a success. The question is really like, how bad was it? Yeah. It came off from this end first, and if you notice, I had to kind of lift it and then it goes back to this end before it would come off. And it looks like I probably took some pads off here, but we can have a way, just clean that area up. In this area, it appears I actually melted the socket, yeah, so this is all this black stuff, this is plastic off the socket. I'm not sure how easily that would clean off. We could have a look. You can see some of these capacitors have moved. One actually jumped clean out of the socket and landed on the board. Another one here, you probably can't see it very well, is actually now sitting on top of the one underneath it. But putting capacitors back, that isn't so much of a problem. We'll keep that one. Let's have a look. Let's just clean some of it up and just let's see how bad that was. Let's get a bit of flux. I'll take the needle off it again. This is a new tube of flux, and I think it's gone a bit hard. Yeah, it's not dispensing well. I've just ordered myself a few new ones. I put a new needle on it, so I don't know why, but it's not when I push, I have to put a lot of pressure. It's got a bit better now, maybe. It doesn't feel as liquid as it normally is. Okay, soldering iron. I spent 5 or 10 minutes. I just see. So the way to clean this up, put the blow in here. To me, probably saw there was a hell of a lot of smoke during that experiment. Yeah, I melted that flux. So we get a ball of solder, yeah, under the iron, and then kind of hover the ball over the board, yeah. It's sticking there. Probably the board isn't quite hot enough. Let's take that off. Just come again with a little bit more. So we just hover this, and effectively, the solder I'm adding is leaded solder, so it mixes with the lead-free solder. Yeah. There we go. And forms an alloy, so it reduces the melting point. Obviously, the more I go over, the more lead-free solder goes into the alloy, so that increases the melting point. So that's why I have to keep going and just, clean it off on the sponge. Yeah. Not sure how well this is going to go over the area where we burnt it. Now, the other problem is I'm sure we've bubbled the board here as well. We've managed to delaminate the board as well. See what happens under this mess. Yeah, this is all actually a mixture of molten plastic. Not sure if we could get that off easily. Let's go back to this. Need some more flux. Get some more flux on the job, eh? This stuff's definitely gone. I think it's been sitting around too long. I've ordered some more, but it'll take a while to get here. So let's just get around this area and keep on cleaning up. It might help actually if I just warm the area of the board a little bit, yeah. Just get a bit of heat into it. There we go. Just to warm it up a little bit to help the soldering iron. Yeah, that's getting a bit easier now. That'll come off, that will. Come on. It'll come. See a little blob here. I can pick it up. There you go. That's gone. So I'm just down to this area now where I had the melted plastic, yeah. See if we can actually do anything with that. I don't think we can. I think we're just making it worse. So we're making a worse mess than we had before. Okay. Bit of solder braid. A bit of desoldering braid. I'll just do this one corner because this is where I think I've ripped some pads. I won't bother do the rest because obviously this is hopeless. Yeah, we're not going to get anything out of this. Put the nozzle back on here. Yeah, a little bit on the braid. A little bit of solder on the iron. Let's go over the pads. Again, I'm not putting any pressure on this, I'm just letting it glide over the board, yeah. That corner is which I'm most interested in. Okay. Let's have a look and see what we've got. Let's get some isopropyl now. Clean it off now. It's under the microscope. Okay. Where's the camera gone? Yeah, I'd actually got the other camera stuck on the end of the microscope, so I'm moving at the same time as this does. So yeah. Okay, so yeah, I've cleaned it up. I didn't bother to clean the solder off this area, but basically it seems to be. No, I won't bother. I can't see any sign of any ripped pads unless there's one here. Is this a ripped pad? Sometimes they're just like tarnished. Yeah, so we've taken the pad off here. I'll look down the microscope, it's easier for me. We've taken the pad off here. But it might be that pad doesn't actually go anywhere. There's a lot of pins under a CPU that don't actually go anywhere, and you can tell if you look at them. Like you see like this pad here, yeah? You see this one here. And it's connecting to a wire into the board, yeah? And you can see these have all got tracks on them, yeah? If you just change the focus slightly, you'll get it, yeah? And these are wires going into the holes that go into the inner layers of the board. But this one that's come off isn't connecting to anything, so it's probably one that didn't matter. These all look okay. This is a sticky mess that's on the board. It certainly doesn't come off with getting it hot, well, not easily. It didn't come off with the isopropyl. It is breaking up, but you might get off with acetone if I had some acetone, but that's one of the problems, yeah, that was. This top corner is the last corner that it didn't want to lift off, yeah. And we can see here that it looks like we've lifted pads. Sometimes they just tarnish, and you can actually. So I can get metal there. But they kind of feel like they're inset slightly, like I've kind of taken some sort of layer off, I don't know. Another one there. Can we actually get solder to stick to them? I mean, let's try. Let's see if we can scrape one off. Yeah, let's see if we can actually get solder to adhere to the pad. Because if solder will adhere to it, then you'd assume that if you put a socket on, the balls, the solder balls would stick. So I'm interested to see whether solder actually sticks to that. Let's have a look. Is it a soldering iron? So we can go to. Let's get a bit of flux as well, because obviously flux is going to help. Let's get a bit of flux on here. Let's have a look to see what's happened to these, yeah? See if we actually could get solder on them or not. There's another one here. Yeah, let's have a look. I'll try with the solder ball again, yeah? Let's see if the solder actually. Yeah, it does. It's gone to the other ones. Okay, so those just by flux looks like we've soldered some of them, so I'm assuming we can solder the other ones. So what we have a little bit of ISO so we can see it. Yeah, I definitely did. You can see that there's now solder on those ones that look tarnish. So yeah, they're okay by the looks of it. We can solder to them. A couple of them I didn't get, but I'm sure they're the same as others. I'm sure if I scrape a bit of that tarnishing off, they'll solder. Yeah. Oh, that's okay. So the other thing, last thing, just show you. The board here is bulged. You can't see it under the microscope easily. but I know that he kind of like delaminated here. His balls a little bit. What's it like underneath? Oh yeah, we've got a good mess underneath it. This looks like molten plastic from the socket has come through. It is. So there must be holes under here, and molten plastic has come through. Okay. Let me just show you the difference with that and the results that I get on the BGA rework station. Yeah. So let's just focus this in again. There we go. This is a gigabyte motherboard, GA1150X. Yeah, ZT, that one. Gaming. I've removed the CPU socket on this one already. It's waiting to have a replacement socket, so it had a lot of very bent pins. Yeah. This is the result we got from using the BGA rework. So you can clearly see the difference in the results between the two. Yeah. You can clearly see the difference. And again, underneath the board on this one, if I get it to focus, so this is like directly beneath the CPU socket. Yeah, it's all clean, look. Okay. Yeah, let's just go back to the overhead camera. So it's quite obvious we have a fairly spectacular failure there, yeah. So I've not tried it before, and I've often wondered. It's not the problem you can't get enough heat in. I could get enough heat in. The problem was that before I could desolder the socket, first of all I delaminated the board. Secondly, I had capacitors actually leaping out of here, yeah. Thirdly, when I did eventually get it to desolder, I'd practically melted the socket to do it. And thirdly, up in this corner, the last corner, this one, I hadn't obviously got enough heat in, but I didn't rip any pads off. Yeah, I've got one pad down here that doesn't seem to go anywhere, so I haven't damaged any pads. I have damaged the board. It's delaminated, and it's very difficult. I don't know if you can even see it. I kind of saw that part of the board is like pop up and it bubbled up. I could touch it with my tweezers and it would go up and down. Now it's cooled down, it's sort of solidified again. But I don't think this would work. So yeah, that's why we have BGA rework stations. Could we make it work? In my opinion, the two things that went wrong here. First of all, I couldn't get enough heat into the board with that preheater. Yeah, I can only get it to about 98, not even 100, even with it on full. I couldn't get enough heat into this board from underneath, from the preheater, to make this doable. Yeah, if I could have got this up nearer to 150 towards 200, or say 180, then I think I could have removed that, because I wouldn't have had to apply much heat from the top. But to do that, we would need a bigger preheater, yeah, which I don't have at the moment, unless someday when I've got 100,000 or more subscribers on here, somebody might be kind enough to send me one, and I'll do a video. If I ever find one cheap, I'll buy one. But obviously I have the BGA rework station, so I don't need to buy one. Let's just have a look though on the internet and just see how much a decent preheater would cost, an infrared one. And let's see how much my BGA rework station is going for these days. Okay, let's go back to AliExpress. So let's have a look for preheater. Yeah, let's see, preheater. Well, these are machines. Oh, we can get preheating stations. I'm not sure how big they are. We want a fairly decent size one. 100 odd euros. Let's try BGA preheater C. We see lots of them here, but I'm not sure. I think these are very small things, like, you know, for mobile phones and such like. We probably want something that's a bit bigger. Something suitable for motherboard size. Yeah, how big's this thing? Oh yeah, the workbench is 400 by 300. Yeah, that's probably big enough to use on the motherboard. So that's like 160 euros for free shipping. And I'm sure there's other ones. Yeah. I think if we use something like that, we could try this again. If I get my hands on something like that, I think this is, you know, let's have another go at it and see if we can get it to work. It's not like we couldn't get enough heat into it. It's just that there was too much heat coming from the top, I would say, and I couldn't get the heat in evenly enough. Yeah. Let's have a look at my BGA rework machine. Yeah, this is the thing. Yeah, so yeah, you can see the price of them. This is my machine. Almost 4,000 euros, and you've seen the job that does of it. That does do it. Plus the postage. Yeah, plus the postage. And we're fortunate on the Canary Islands. We'd only pay 7% duty. Yeah, no, that'd be 21% on top of that in mainland Europe. Okay, so that's that. So as a final thought, then, really, yeah, you can see the difference it makes. We can understand why we need that sort of equipment. I'd be very interested to try this again on a good sized preheater suitable for the size of the board. If I can get my hands on one, that's something I would try. Other than that, guys, well, I don't know. Did you enjoy that? It failed, but I've never seen anybody else try to do this on YouTube with this sort of kit, and now we know why. Yeah, because I'm the only one daft enough to actually come along here and show you what doesn't work. Okay, have fun, guys, and I'll see you soon on another video.